All right. Okay. So welcome to Eureka Squared or Eureka Math Squared, grade 6. This is lesson 4, discussing least common multiple. All right. So in lesson 1, we talked about multiples. Okay. And multiples being the result of, well, multiplying, right? So if we have the multiples of 4, we need a 4 times 1, which is 4, a 4 times 2, which is 8, a 4 times 3, which is 12, and so on, right? So those are all multiples. If we needed the multiples for 5, right, we would start with, whoops, a little arrow there. 5 times 1 gives me 5, 5 times 2, 5 times 3, 5 times 4, right? So 5 times 5, 5 times 6, and so on until we get a match, right? So if I go back up here and I do a 16, and then I got a 20, and I'd say, ooh, there's my least common multiple between those guys, right? And that would be fine. But today, well, I'm going to show you what I think is a faster method, okay, using what's called prime factorization, right? Prime factorization. Now, in lesson 3, we did prime factorization a bit. So this is exactly the same, well, with a little bit of a twist. So we used prime factorization to find common factors. Now we're going to use it for finding common multiples, or at least the least common multiple. Okay, so let's see what's up here. Here's how it's going to work. So let's cruise on down here, and I have some areas that are checked off I want to deal with. Okay, so we're going to consider these two numbers. We're going to find the least common multiple. Now, normally I would take 11, and I would just start, oh gosh, 11, 22, 33, and skip count, right? So 55, 66, 77, and so on. And then I do a little bit of a 12, and 24, and a 36, and a 48. And as you can see, this is becoming a little bit of a pain in the neck, right? So 60, and then a 72, and oh my gosh, where is this going to end? And if you make a little mistake along the way, you're in trouble. Okay, so what we're going to do is actually use a prime factorization method. So here we go. So I'm going to list the two numbers, and just like in the last video, I'm simply going to list the two factors of any two factors of 11. Now, the only numbers that you can actually multiply are 1 times 11, right? So 11 is a prime number to begin with. So I'm going to circle the 11 because it's already prime. And well, we can't factor it at all because it only has two factors because it is prime. But the 12 we can deal with. So I'm going to do a little 3 times a 4. That gives me 12. And a little 2 times 2 will give me 4. Okay, now here's how it works for the LCM, right? What I'm going to actually do is run the GCF first, the same way as in the previous lesson, which was lesson 3, right? So the GCF, I'm going to look for any common circled values, which I don't have any, right? So none. Okay. And then what I'm going to do is list every circled number that I haven't used and multiply those, and that's going to give me the LCM. So since there are none here for the GCF, every circled number is then going to have to be multiplied. 11 times 3 times the 2 times the 2, right? So there's the 11, the 3, the 2, and the 2. I have to put everything down, multiply all those together, and that's going to give you your LCM. Okay, so these two give me a 33. These two give me a 4. I then need a 33 times a 4. So that gives me 12, 12, 13, 132. And there we go. Just like that, I have an LCM of 132. Now, I would have had to, over here, to keep on skip counting until I found 132 was a common value or common multiple. In this case, I was already done very quickly. Okay, so that's how it works. Let's see if we can actually put this into practice a little bit. I have all kinds of fun stuff for you, but I'm going to keep scrolling down until I find something I checked off that I actually want to work with you to give you the best examples of what I'm talking about. Okay, so here we go. Now, like I said, I don't want to do this, right? I don't want to list all these buggers out here. So consider numbers 2 and 3, right? I can list them out: 6, 8, 10, 12, 14, 16, 18, 20, right? 3, 6, 9, 12, 15, and look for an LCM. And sometimes it's pretty easy, right? It's pretty quick, right? So there's a 6 and a 6. There's my LCM. But using prime factorization, it works pretty well too. Watch. So if I use a 2 and a 3, there's my 2, there's my 3. 2 is automatically prime. 3 is automatically prime, right? So a GCF, right, that has to be a 1 because there are no common factors, right? So it's none, right? So it has to be a 1. And my LCM simply means, hey, multiply what's left. The 2 times the 3. So 2 times 3 gives me 6, and I am done. Okay, now again, that wasn't the best example. This one's going to work out pretty well. Okay, so here we go. Here's a 10, and here's a 12, and here's a 10. So I'm going to work for the GCF first. Okay, so a 2 times a 6. 2 is prime, so I circle it. From the 6, I have a 2 times a 3, right? So those are both prime, so I circle those. Cruise on over to the 10 land over here. I have a 2 times a 5. They're both prime, so I circle those. Okay, so run the GCF. GCF, okay, so I have a 2 over here and a 2 over there. When I have a match, I list it. Do I have another match? Let's see, I have a 2 over here, but no 2 over here. I have a 3 over here, but no 3 over here. On the other side, I have a 5, but no 5. So guess what? The GCF is 2. Now check this out. Here comes the LCM. You ready? Bring that 2 down. Okay, that was the good part. Bring that 2 down. Okay, and now simply take all the extra circled ones that we haven't used, right? So that 2's gone, that 2's gone. So we bring the GCF down, we need the GCF, and then take every circled number that we haven't used and put it in your multiplication problem. Watch. So there's, put the 2, there it is, that 2. There's that 3 from there, and here's that 5. We haven't used those. Put those all in there, multiply those, and that's your LCM. It's kind of neat. Watch. So that's a 4. This is great, right? Times a 15. Take your 4 times 15, you get your 60, and guess what? LCM is 60. Works like a charm, right? Pretty cool, and you're done. So now you have your GCF and your LCM just like that. Okay, so let's run another one super quick. How about that 9 and a 12? 9 and a 12. So last one, we'll do another one here. 9 and 12. So let's break that up into 2 3s, right? So 3 times 3 gives me 9. They're prime, so I circle those. Let's do a 3 times a 4. The 3 I circled, right, because that's prime, but the 4, that could be broken up into a couple of 2s, right? So those guys are prime. They're done. So let's run the GCF. Now, if you're good with the GCF, you're going to be great with the LCM. If you can't find the GCF using this method, then the LCM method really isn't going to work for you at all. Okay, so let's see. I have a couple of 3s, 1 3 on each side, so I'm going to list that down. All right. Now, I do have another 3 here, but no 3 over here, so no good. Now I'm going to cruise on to this side. I have a couple of 2s here, but no 2s. So guess what? GCF equals 3, so that's done. Now for the LCM. Bring down that 3. Okay, so he cruises down just like that. And now all I do is list all the numbers that are circled I did not use yet, all of them. So, and put them in your multiplication. So here's a 3, I'm going to put it down. And those 2 2s, there's one of them, there's the other. All I do is multiply these guys, and that's my LCM. So 3 times 3 is 9, 2 times 2 is 4, 9 times 4 is 36, and I am done. So the GCF for those 2 values is a 3, and the LCM for those 2 values is 36, just like that. Okay, so that's the deal, folks. That's using prime factorization to find, well, both the GCF and the LCM. And yeah, so I hope it goes well for you. Hope you enjoyed that. Take care, folks. So long. Bye-bye.